This video is going to show you how to factor using the distributive property. We've also used this property in the past when we were factoring in section 10.6, but we called it the grouping method. So really the factoring using the distributive property or the grouping method is pretty much the same thing. The polynomials in section 10.8 are going to have 4 terms. So typically we're used to seeing something with only 3 terms or 2 terms, but in this case it'll have 4 terms. So these polynomials are set up for us to solve using, to factor using the distributive property or the grouping method, which we talked about earlier in the chapter. So just like when we did the grouping method, we're going to group the first 2 terms together and the second 2 terms together. We're going to factor out the GCF in each binomial. So when I look at my first binomial, I have x cubed plus 2x squared. So my GCF is going to be x squared. When I factor out an x squared, I'm going to get x plus 2 inside my binomial. Okay, now I need to factor out my GCF in my binomial, which is 3x plus 6. So my greatest common factor is going to be 3. So when I take a 3 out, I'm left with x plus 6. X plus 2. Let me erase that. I'm going to be left with x plus 2. Okay, a couple things are happening right here. First of all, you'll notice that these 2 binomials are exactly the same as they should be. All right, and my greatest common factors are going to be written out here, so in front of the 2 binomials. From here, what I'm going to do is I'm going to use the reverse distributive property to write my answer. So my answer is going to look like x squared plus 3 in parentheses times x plus 2. As always, to check my final answer, I can use the FOIL method to multiply these 2 binomials out. And if I get my original polynomial, I know I did my work right. So here is my answer in factored form. Here's the next polynomial I need to factor. X cubed plus x squared minus 4x minus 4. So just like in my last example, I'm going to go ahead and I'm going to group the first 2 terms together and the second 2 terms together. Now this one's a little tricky because I have a subtraction sign right here. So I want to make sure that I don't lose that negative or the subtraction. Okay, so I'm going to go ahead and I'm going to factor out the GCF out of my first binomial. So my GCF is going to be x squared. So I'll get x squared times x plus 1. Then I'm going to go ahead and factor out my GCF out of my second binomial. Now if you remember what happened in my last example, I had 2 matching binomials. So my goal here is to get an x plus 1 to be left inside this set of parentheses here. So it matches my first set of parentheses, so I can use the reverse distributive property to factor my answer. Now in order for me to get x plus 1 here, I need to factor out a negative 4. So just to double check my work here, if I do negative 4 times x, I'll get negative 4x, and negative 4 times 1, I'll get negative 4. So that tells me I correctly and properly factored out the greatest common factor, which is negative 4. Now if you feel the need to change this to plus a negative, go right ahead. All right, so just like in the last example, I'm going to go ahead and put my binomials together, starting with x plus 1. So that's a repeat, so I'm going to write that first. Doesn't matter what order you write it, though, but I'll put it first. And then my second binomial is going to be x squared minus 4. Now, I'm not officially or finally, I don't have this finally factored. I hope you notice that x squared minus 4 is a difference of squares, so I can factor that again. So when we did section 10.7, we factored x squared minus 4 into x plus 2 times x minus 2. Then, of course, I need to bring down x plus 1 in my problem. So my final answer is 3 binomials, x plus 1 times x plus 2 times x minus 2. So this is factored completely. The last check I always want to do when I'm factoring is to see if I have any greatest common factors left inside my binomials, in which case I don't, so I know that this is the final answer. The absolute last thing that I can do is check my work by multiplying these binomials together. And again, if I get this polynomial up here, then I know I did my work correctly.